Do you trust AI models? No. Hey, nice to see me. So if I give you a trained model you don't trust? No, because I don't trust you. I'm kidding. I'm willing to trust your AI model, but not necessarily at the beginning. Can you explain a little bit more? Well, sometimes there's lack of explainability. I want to understand how the model is interpreting the input data to come up with that predicted value. Sometimes there is maybe unfair behavior within the performance of my model due to different reasons, for example, unbiased data. And when the errors are happening, I want to understand the root of those errors and under what circumstances those are happening. And then I can do some what if scenario analysis. Excellent points. Now, if I tell you that there are some responsible AI toolkits that you can use them in your code to assess all the points you just mentioned, will you give it a try? You mean hands-on and in action? Yes? Oh, of course. I would love to know more about it. Then, if you want to know more about it as well and give it a try, come with us. What? What do you mean, come with us? Where? They're just watching the video. I know, I just wanted to make it a little bit cool. Oh, so professional. Then, come with us. Hello everyone, I am MG. Actually, we are MG. We are data scientist and cloud solution architect, and in this video we are going to showcase you how we can leverage some open source responsible AI toolkits to support you with some of the points and concerns that I just mentioned to me within the code and visualize them in action. So let's check them out. Right now I'm using Azure Machine Learning as a choice of IDE, but it can be anything. You just need to install the library and you're good to go, and I'll walk through the code and show you the dashboard. But before going further, again, I'm highlighting the fact that I'm using just Azure ML as an IDE. For some of you who have never seen or heard about this service, that's a platform as service running on Microsoft Azure that will allow you to have a collaborative environment within your data scientist team to develop use cases altogether. Not just for the development, all the way for the production, creating a deployed model, having an endpoint to leverage for the services that they're going to provide. So here I have opened a notebook in Azure Machine Learning, and I had the flexibility of choosing a compute machine. It can be CPU-based, GPU-based, a cluster of nodes of machines. But for this example, I used a pretty light data set coming from scikit-learn. You might be already familiar with the diabetes data set. This data set actually contains some features like age, sex, BMI, blood pressure, and some other components which are related to blood, like cholesterol levels, sodium levels, so on and so forth. And then I am just very simple and quickly training a random forest regressor to have a regression model to predict what would be the progress of diabetics of a patient who has diabetics over a year. I have trained the model, and that's the time that I want to apply those responsible AI dashboard to see those toolkits. And this is not only can be used for me as a data scientist or for someone who's a machine learning engineer, and even people who are in the business side, that they want to have a better understanding of how those principles are applied here. Again, that's a socio-technical challenge, and what we are showcasing here is just a tool to help you to have the responsible AI solution. So after running this code and computing my responsible AI insights, it is giving me a URL that is running on Azure ML Compute. And that's the exciting part. I'm waiting to load the toolkits, and you can see the first plot is starting with error analysis. So here's the question. For sure, whenever we train a model, we come up with some error ranges. We say, well, this is the metric I have used accuracy. I'm 90% accuracy, 92% accuracy, and so on and so forth. But still, there are some chances that we might come up with a prediction which is error. And this is not the true value that we're looking for. So is there any way that I can detect at least the root of why those errors are happening, and something that can give me some insights in what specific conditions
I have the higher chance of getting errors based on the test data set, for example, I provided. This is actually a toolkit that can support you with that. You can see this tree visualization is telling me that some of the color of these circles are more red, which means there are more error generated there. So if I click, let's say on this one, it shows that in my data set, when I have the age less than this value, and by the way, all of these values are scaled by scikit-learn. I think it's mean centered by, and also number of samples multiplied by standard deviation. That's why some of these numbers, it's not realistic, but they're all scaled based on real values. So when I clicked on, it shows that when I have this condition, 70% of the errors are happening. So that's the initial hint that I got, that now I need to think about it. If I'm a healthcare provider, if I'm a data scientist, if I'm a part of medical staff team, now that's the time I can tweak my domain knowledge, or as data science, my data science knowledge, to think about some treatment as of now, or no, I want to go further and see what else I can get from. Well, let me save that as a cohort. What I can do, I can save this cohort that is selected as a new one, and I give it a name. I'll choose the same thing for give it a name for age less than 0.02, which is again scale value. And afterwards, I can just switch to the cohort that I created. Now you can see I'm just seeing the error analysis tree just based on this path that I filtered. Still, after having that condition, I have red color here, and if I click on that, it's telling me now this S-row value, which is I think the close to level, is more than this scale value. I have 60% error coverage, and that's the mean squared error. So that means when the age is this and the S-row feature is this, that's the pattern that I saw, that my errors are distributed more there. That's the time that I got a good hint that what is happening on the back end. And now you see that how I'm interpreting the model to make it transparent for everyone, how the model is behaving, right? So let's move a little bit more. That's the time that I want to understand the model a little bit better based on what I just saw here. Well, you can see this chart is telling me how the errors are distributed based on all the data when the age is less than this amount, because we just filtered on the top. And also I want to see how the errors are distributed based on different ranges of these features, S4 or close to level. Because if I click on heat map and select the S4 feature, which is a feature of interest, and I'm curious to know more about it, this heat map is telling me that, for example, when S4 or close to level is between this range, 100% all the time I have error, or less for other ranges. So there should be something, let's say there's a bias sample of features of S4 maybe, that I have less amount for this range that the model hasn't trained yet or hasn't fully learned properly. So let's scroll a little bit down. Now I want to see the error distribution for that feature. I click on cohort, clicking on data set. And now I can select S4 as my selected feature, clicking on select. There you go. Now I see for some of these ranges, which are the same on the top, the inter-quarter range of errors which are distributed are shrink, but some of them are more expanded. So it clearly shows that how my model is performing within different ranges of that feature, and I have different distributed ranges of errors. Now I want to dig a little bit more on the data and explore the data specifically for this feature. Scrolling down, that's the time that I hit Data Explorer. What I'm going to do right now, I want to see the count of S4 or close to level feature to see if I have biased sort of collection of the data for this feature or not. That's why maybe the errors are distributed not equally within the feature ranges. So what I can do, I can say the index I would like to be, again, the same close to level feature S4. And here I want to see their count. There you go. So my initial hypothesis is somehow getting true. Again, not the final decision, but you see that how these toolkits are supporting me with those principles of responsibility I told you. So I want to match that picture and slide to what we are doing right now. I can see for this range of close to level, again, scale values, I have quite high number compared to rest of samples here. And if I check the same range on the top here, which is this one, you can see the inter-quarter range of errors for this range is more shrinked than the rest. And vice versa, for the last one that I have less value, less samples that the model can get an idea from, I have a little bit more wider range of interquarter range. So you could see that how from error analysis, model statistics, and the data explorer, these stories and patterns came to my mind to support me with coming up with the treatment analysis. So shall I go and ask for the medical staff or the data source provider for more samples within that feature before telling that this is a model with this accuracy or precision, or here are the metrics of regression, let's say RMSE, and say we are done? No, we have to come up with some guardrails and also make sure we understand the process. Moving a little bit further, not only that, now in general, I want to know how my model is utilizing these features to come up with a prediction. Which one is more important and which one is less important? You can see the orange color, which is all the data that I used. Model valued the S5 feature as the highest one, and then BMI, body mass index, and again, blood pressure, S3, which are again some other blood factors, so on and so forth. But when the age is less than this value, because we filtered on the top, sometimes the importance of features is getting a little bit changed. As you can see, there's a slight difference between. So it is telling me an idea, again, as a person who's a data scientist or has domain knowledge, does that make sense? If the age is getting younger, the other feature should be more important than the rest, and the when age is older, vice versa? Is it something that's totally fair to interpret these features and data set in this way, or the model is just have learned kind of correlation that there is no causation behind, and we have to make sure this is a proper way to come up with a prediction for the end user? Not only that, for any individual predictions that we have done, if I click on the tab here, let's say the first one, this is the true value, predicted value, and the rest of the scale features. If I select any of them and I scroll down, you can see in the chart for that specific prediction, which features were highly valued by the model and which are less. So I can also track this bar to see more features and how they're evaluated based on the importance. And if I click on individual condition expectation, this is the interesting part. That can show me how just changing the age for that specific data that I just chose, how the prediction of diabetics will be different. So you can see when the age is getting older, that specific prediction of diabetes is getting higher and higher and higher. So from almost 95 and 90, and then all the way close to 100. Again, I'm not going to interpret, I'm not a medical doctor, but I'm saying, well, does that make sense when the age is getting higher? So the chance of probability of having a little bit worse progress on the diabetics is high. That's the decision that can be made by human. Last but not least, what if counterfactuals? This is also very interesting to still dig a little bit more on your data, understand how your model is performing. You can see here I have index, I can filter them based on any type of features and values that I want to see. These are all different type of data set that we have done the prediction. Let me just randomly select any of them. And this is based on the age because it is age has been selected, but I can certainly change it. And here you can see how for that age, which features and how they were important for the prediction. But the cool part is I can create some what if counterfactual scenarios. So with clicking on this button here, you can see that this is the true value, the reference data point, and these are different predictions that we have done in a way that we have changed some of the features. So what is, first of all, what if counterfactuals, and how come we came up with these numbers? The scenario here is, what would be the minimum change that we can do in the features, maybe just one feature, maybe just flipping the age from male to female, or maybe just flipping the gender from female to male, or just flipping the age, I can totally change and flip the prediction. So that's what we're trying to understand. And these are some of the examples that this toolkit automatically created for me. For instance, here you can see one of the counterfactual examples is 99, which is much less than the reference point. So the prediction is reduced for the diabetics progress. But we got to see what features and how was changed to reduce that considerable amount. So if I scroll a little bit to the left, you can see, first of all, the BMI has been changed. The BMI from a higher value is decreased to a lower value. Probably that makes sense that at the same time, the diabetics level also reduced. And what else? The second feature, I think, is S4 has been also increased as well. So then we have to check what is that factor that is changing that and or increasing that is affecting the prediction in a way that we will have a lower value in our prediction. So again, this is a very powerful tool to give me an idea of what if a minimum change can be done to totally flip the prediction. And if you want to have more customized counterfactuals or what if scenarios, here you can play around with all the features that we have. Just change one feature, change two features in any potential value that you want to see what's going to be the final prediction. For example, now the current prediction is 188. If I just change this value of the age, 0.02. Okay. I don't know why my notepad is not working. Let me see. Okay, it sounds like my keyboard is not working. That's a live demo. Something should fail. But in general, let me try this one. If I probably have 0 on this one, this should it was 188 and now we can say it is 186. So on the fly, with changing any values of features here, the prediction going to change. And with having those data points, we can save them and probably later on plot them to see, again, as a person who has a domain knowledge, as a data scientist who has been involved and hands-on with a solution, does the way that the model is interpreting the data make sense or not? Is it aligned with the guidelines that you have defined for your principles in responsible AI or not?
Excellent. You just saw that how we were able to leverage these open source responsible AI toolkits to understand the behavior of our model better. Remember, that's a socio-technical challenge, and it doesn't mean having these codes and toolkits is end of the story. But at least these can support you and push you further towards a responsible AI-based solution. We hope you enjoyed the video, and until next time and the next video, see you later.